See that?
Yes, excellent. Please project.
Good afternoon, everyone. Today my topic is transmission electron microscopy. So this figure shows one of the Titan transmission electron microscopy we are using in the collab, and it consists of three systems: the illumination system, the state imaging system, and the image recording system. So how it works? Firstly, the electrons will be ejected from the electron gun, and the condenser lens will have to deliver the electrons from the gun to the spaceman. And here is the spaceman, and above the spaceman is the objective lens. And the objective lens is the most important lens in the system, because the spherical aberration of the objective lens will determine the resolution of the TM. And after that, the intermediate lens will allow either an image or diffraction pattern we can get, and the projector lens will have to record the information. So why we call this technique the transmission electron microscopy? It depends on the electrons it uses. So this figure shows different types of electrons and the information they provide. So when an electron beam reaches the surface of a very thin sample, it will be scattered. And the different kinds of electrons will be gated. For example, the secondary electrons is very important in the SEM system, and the characteristic X-ray, so it can give us the information of the elements. And at the same time, we can also get the transmitted electrons that the most important one we are using is the TEM system. It can tell us the morphological information of our samples. So the next slide shows some examples of the application of TEM. Firstly, the high resolution TEM image. When the resolution of the TEM is very high, we can see the more information of the crystal structures, the lattice, and the atoms, and so on, as shown in these figures. And the second one is mapping. As we have mentioned, the index will tell us the elemental information. So here is a composite, and the TM can tell us what kind of element it contains and the distribution of the elements. Here is carbon, nitrogen, and oxygen, and this is a composite. And the third application is selected area diffraction patterns. So this point will tell us a lot of information about the crystal structure, the crystal plane diffraction, and so on. And recently, the Institute TM, there are a lot of research about this one. It will tell us what happens during the reactions. For example, this figure shows the excitation process of a silicon particle in the battery system. It shows how the lithium is interconnected into the electrodes. The last slide is about some other information of TM. Here is a comparison with between TM and other system. The TM uses transmitted electrons, and it gives us the two-dimensional morphology information and the diffraction patterns of the materials. And the resolution is very high. It's higher than 0.01 nanometer. And there are a lot of famous manufacturers of TM. For example, the Titan TM we are using in the collab comes from the FEI company, and the High-Tech and Geo are also very famous around the world. So the cost of the TM depends on a lot of things. For example, the resolution, the operating voltage, the correction mode, and the accessories, and so on. Most of the TM systems are very expensive. They're over $1 million. And so that's all about my presentation. Thanks for your attention. Any question?